Okay, let's dive right into this. Listen, if you've spent, any amount of time working with large language models, you've definitely felt the pain of an AI hallucination. It's when the model just confidently tells you something that is completely hilariously wrong. It's a massive headache, right? Especially when you're trying to do serious work. But what if I told you there's a specific prompting superpower to fix this? Welcome to today's explainer, where we're going to unpack a really brilliant breakthrough called generated knowledge. This is a method that literally forces the AI to check its own facts, which dramatically boosts its accuracy and reliability. All right, let's get started. So, here's our roadmap for today. We're going to cover what generated knowledge actually is, single versus dual prompting, how to fix those confident AI mistakes, the actual technical mechanics under the hood, and finally, we'll wrap up with recitation augmented models. Let's kick things off with Section 1. What exactly is generated knowledge? To put it simply, the generated knowledge approach is when you explicitly prompt a large language model to generate useful, relevant facts about a topic before you actually let it produce its final response. Think of it kind of like making the AI do its homework or brainstorm on a whiteboard before it actually sits down to write the final essay. By forcing the AI to pull up and lay out the facts first, you're basically building this solid foundation of truth that the final answer can rest on. And this brilliantly illustrates why this technique is just so incredibly powerful. First off, it directly anchors the AI's response in factual information right from the get-go. It acts as a sort of intermediate reasoning. If you're familiar with chain of thought prompting, well, it's very similar to that. But instead of just thinking logically step by step, the model is generating related factual context. And ultimately, this leads to content that is significantly more informative, more accurate, and way more reliable. It grounds the AI in reality rather than just letting it take a wild guess. So, how do we actually put this into practice? That brings us to Section 2, single versus dual prompting. There are two primary ways you can apply this technique in your everyday prompt engineering. In the single prompt approach, you combine the fact generation and the final response into just one single instruction. You might say something like, list 5 facts about spirit bears and then write a blog post about them. Pretty straightforward. But by contrast, the dual prompt approach separates this whole thing into distinct steps. First, you prompt the AI to just generate the facts. Then, in a completely separate prompt, you feed those exact facts back into the model and then ask for the blog post. And here's the thing. If you're aiming for high-quality, long-form content, you absolutely want to use the dual prompt method. It is highly recommended because it produces longer, much more reliable outputs. Now that we've got the workflow down, it's time to see this superpower in action. Let's step into the conflict with Section 3, fixing confident AI mistakes. Consider this deceptively simple geography question that early models like GPT-3 famously struggled with. Which country is larger, Congo or South Africa? Now, to a human looking at a map, this seems incredibly straightforward, right? But without proper prompting, AI models can easily stumble on this exact type of factual retrieval. If you just ask the question directly, here's the output you get. South Africa is larger than Congo. And the AI states it with total confidence. It's essentially mansplaining geography to you. But there's a major problem here. It is completely, undeniably, incorrect. The model just hallucinated a geographical inaccuracy and presented it as absolute fact. No way, right? Well, this is exactly why we need the generated knowledge approach. So the crucial point is how we actually fix this using our two-step dual prompt method. Step 1 is knowledge generation. We hit pause and we prompt the AI strictly to generate facts about the sizes of both South Africa and Congo. We don't ask it to compare them yet, we literally just ask for the raw data. Then step 2 is knowledge integration. Once the AI outputs the data, for instance noting that Congo is around 2.3 million square kilometers while South Africa is about 1.2 million, we feed that generated text right back into the prompt and ask our original question again. And check out the result of that process. By forcing the AI to generate the facts first and then integrate them, the corrected output is absolutely flawless. Congo is larger than South Africa. We successfully guided the AI to its own factual conclusions before it was ever allowed to answer, which completely eliminated the hallucination, a real game changer. So that's the practical, everyday use case. But what's actually happening inside the AI's brain? Well, that brings us to Section 4, the technical mechanics. This generated knowledge approach was formally introduced in a really cool breakthrough academic paper by researchers Liu and colleagues. It was initially aimed at improving a model's common sense reasoning. Technically speaking, it works by prompting the model in a few-shot fashion, which basically means giving it a few examples to learn from right there in the prompt. Behind the scenes, the model generates M number of different fact completions. So it doesn't just brainstorm one fact, it brainstorms multiple distinct factual pathways before it ever even attempts to answer the core question. To test this, the researchers used a classic fill-in-the-blank question. Most kangaroos have masked limbs. The whole goal here is for the AI model to accurately figure out exactly what goes in that blank. Now, what's really interesting here is how the math plays out. Let's say our model generated two different pieces of knowledge, so m equals 2. Knowledge 1 says kangaroos are marsupials in Australia. Knowledge 2 says kangaroos are marsupials with 5 limbs. And actually, side note, that is amazingly biologically accurate if you count their strong muscular tail, which they use for locomotion. Anyway, the system then concatenates each piece of knowledge with the original question to create an augmented question. This leads directly to two distinct proposed answers, 4 and 5. So, how does the AI decide which of those proposed answers is the ultimate winner? Well, mathematically, the final answer is selected by calculating the highest probability of the answer token. This is often done using complex calculations like softmax or log probability. But to put that into simpler terms, the system just selects the answer that occurs most frequently across all the generated knowledge variations. It's effectively taking a statistical vote based on the facts it just brainstormed. Pretty wild, right? Which brings us to some really fascinating alternative research in Section 5, recitation augmented models. While the LU framework is incredibly effective, another group of researchers, Sun and colleagues, introduced a more streamlined alternative called the recitation augmented approach. The original generated knowledge framework is this strict, somewhat complex pipeline that splits generation and integration into very distinct automated steps. But the recitation augmented approach, it collapses this entirely. It uses few-shot prompting to provide exemplars that show a question, a recitation of facts, and an answer, all bundled together. This forces the model to generate the factual information and answer the question in the exact same automated step. It's just a slightly different, highly efficient path to the exact same destination. So, let's bring this whole shebang together. What should you really take away from this explainer? Well, whether you're using a single prompt, a dual prompt, or complex automated pipelines, the core philosophy remains exactly the same. You must force the AI to brainstorm facts before finalizing its output. This intermediate reasoning mirrors the effectiveness of chain-of-thought prompting, but it focuses entirely on factual grounding rather than just logical steps. Oh, and just a quick terminology note before we finish. The specific piece of knowledge that ultimately leads to the final winning answer, that's officially referred to as the selected knowledge. Which leaves us with a fascinating thought to end on. As these AI models continue to evolve, become larger, and train on more and more data, will they eventually learn to automatically generate their own internal knowledge before speaking entirely on their own? Or will human engineers always need to step in and prompt them to think first? It's a really critical question for the future of prompt engineering. Keep experimenting with your prompts, keep forcing those facts, and keep learning. Thanks for joining me on this explainer, and I'll catch you next time.